increase power density and big grid capacity. And now market is growing like anything. And many charging unique ways of doing 2-3 units, 80 industrial company, solar company, SSC. So he ordered 2 chargers, low cost charger, level 2 charger, level 3 charger, and electrical product material launch patent both the product fast charging, home charging, so both the innovation. So that the level 1 charging, it is very slow. How long time? So battery swapping technology. Last time we were actually electric vehicle, and today is electric charging. So level 1 charging includes 124 or 2 chargers, AC block, and level 2 charger, 240 volt and 450 volt, and this up to the 20 kilowatt also we can go, and there are moderate speed, and DC fast charging is generally public residential and high quantity, high power requirement. High power requirement battery are very quickly charged. So there is battery life cycle. In solar plant and design 2 volt per battery generator. So 2 volt like Tesla car 1.6, 2.2 volt like that. So बहुत बड़े 2 volt cell connect करिए जरा हमारा thermal management के लिए बहुत easy है. और second के चीज़ करो local hotspot create करेंगे. अब गोटे बैटरी मध्य short है ले पूरा overall battery efficiency very high. Then बड़ा बैटरी use करिए 12 volt use करिए बदल रहे हम 1.5 volt cell पूरा कैस्केडेड करिए. किंतु सेट गोटे प्रॉब्लम पर BMS जो छोटे सेल है BMS became very critical. और हमारा क्लस्टर और पूरा पैक लेवल टेम्परेचर एंड इंडिविजुअल टेम्परेचर बहुत डिफरेंस है. तो से चीज थोड़ा बड़े चैलेंजेस इनके हाई बिकॉज बहुत बड़े कम ये इंटरेस्ट कर दिया टाइम हमें बहुत हाई स्पीड वाटर जेट हमारे कुछ समय पर पत्थर में धीरे-धीरे बढ़ एग्जैक्टली हमने बैटरी में हाई स्पीड चार्ज किया बैटरी में कैलकुलेशन तो सेटा बहुत फंडामेंटल फिजिक्स स्टडी है सेटा हमने पूरा डिटेल पढ़ी बट हमारा थर्मल इमेज है हम सब देखो मेजरमेंट बैटरी का चार्ज मेजर चार्ज डिस्ट्रीब्यूशन तो सेटा का then Tesla supercharger they are very quickly discharged and our solution multi-level multi-port charger in the
this all of the switch off your mobile or silent
जिनके हमें मुझे RR है इलेक्ट्रिक चार्जिंग स्टेशन तो तांकर 48 volt 60 volt 24 तीन प्रकार बैटरी तांकर चार्ज तो गोटे ट्रांसफॉर्मर मल्टी पोर्ट चार्जर डिजाइन करिया द्वारा सेटा हमर कॉस्ट रिडक्शन होची आउ कैपेबिलिटी पावर कैपेबिलिटी बहुत ही ता विषय में हमें इंडियन sustainable usage, efficient management, improve grid stability. ଯେତେବେଳେ ଆମେ vehicle ମଧ୍ୟ ଦେଇପାରିବା grid ଦେଇପାରିବା grid stability, battery health and lifespan. ଆମେ ଗୋଟେ artificial intelligence use କରି ଆମେ जो battery तार life cycle ଆମେ test करते कितने life cycle पर by using artificial intelligence we predict that 1500 1300 accordingly ଆମେ ସେଟା use କରୁଛେ तो कितने लाइफ साइकिल पर बैटरी का दैट इज आल्सो वेरी इंपोर्टेंट रिसर्च आमे जनरली फंडामेंटल रिसर्च आमे के करने जनरली आमे डायरेक्टली सर्किट हम जो मैनेज करछे तार काम सोलर इंजीनियरिंग कुछ पेपर पब्लिश करना तो प्रकृତରେ स्टूडेंट मानन हम बहुत फंडामेंटल ताको इतने बड़ काम करिया दरकार रिसर्च जाने करछे हम से चेक करते या कोई स्टूडेंट के ऐसे हम तो कोई इंडक्शन मोटर डिजाइन से पूरा बहुत दुखी है ना तो मास्टर पते से दुख पहले सार कौन प्रॉब्लम मत देखो पहले इंडक्शन मोटर सबवर से अवेलेबल लैब है सब जगह है कि मुद्दा कोई तो इंडक्शन मोटर ही तो डिजाइन से ताकि कहले ताकि इंडक्शन मोटर स्पेसिफिकेशन 110 वोल्ट बैटरी सप्लाई low voltage 80 hertz machine lamination thickness 0.35 क्योंकि आज बोलते इंडिया डेवलपिंग है कोरियर वाले को lamination and से डेवलप किया 3टा पेटेंट and 4टा IEEE ट्रांजेक्शन केवल इंडक्शन मोटर डिजाइन ऑप्टिमाइज डिजाइन करो 92% एफिशिएंसी अपना वाले को इंडक्शन मोटर 92% then very last year India government DRDO Defense Research Organization सेवने वर्तमान में जेट इंजन बनाया है 1.6 करोड़ last month में sanction करा 1.6 करोड़ very high speed 15,000 RPM और 15,000 RPM से ड्राइव करियो और सीधा integrated ये independent computing और सीधा एक बड़ा बॉक्स से फिट हो जुड़े जेट इंजन का प्रोपेलर है तो मोटर डिजाइन में बहुत वर्तमान इंडिया में किए ना प्रोफेसर ऐसे समूर्ति से IIT दिल्ली में से तो रिटायर्ड करेंगे लास्ट फेज ताकि से मरिया ताकि बहुत 87 है तो इसे जानी तो ना आउ वर्तमान इंडिया रे आउ मोटर डिजाइन पर क्या रिलेटेड व्हीकल कंपनी अप्रोच करते हैं आप ये मोटर बनाओ ये मोटर डिजाइन बहुत बड़ा फील्ड किंतु आम से बहुत नेग्लेक्ट करिए तो मोटर से तो इंटीग्रेटेड चार्जर वर्तमान आने वाले काम करते इंटीग्रेटेड मींस मोटर वाइंडिंग ही हमारे इंडक्टर को काम करेगा फिल्टर को काम करेगा सेंट्रल में चार्ज गोटे वाइंडिंग मोटर रन करियो अन्य गोटे वाइंडिंग चार्ज मल्टी वाइंडिंग चार्जिंग विथ मोटर एट इज वन प्रोजेक्ट है हम जस्ट सबमिट कर चुके हैं सो एट तो इकोनॉमिक बेनिफिट एंड सपोर्ट रिपोर्ट एंड अगर हम कोई देखिए मल्टी पोर्ट चार्जर जैसे हम गोटे इलेक्ट्रिक व्हीकल देखिए से इलेक्ट्रिक व्हीकल रे अराउंड 26 चार्जिंग पोर्ट काफी 5 वोल्ट जोटा एसएमपी से हम कंप्यूटर भीतर अच्छी कोडा पे 12 वोल्ट दरकार कीबोर्ड पे 12 वोल्ट मॉनिटर पे 12 वोल्ट पूरा पे माउस पे 5 वोल्ट दिस डिफरेंट मल्टी पोर्ट चार्जर डेवलपमेंट इज वेरी इंपॉर्टेंट सी द इलेक्ट्रिक मल्टी पोर्ट सिस्टम अच्छी से लाइट पे दरकार इसमें हॉल पे दरकार सब दरकार तो से मल्टी पोर्ट चार्जर ऑलवेज वेरी कॉम्पैक्ट as a multi-port charger बहुत ही important है चार्जर और second one multi-level control जैसे आप voltage 800 volt होगा the two level voltage will give lot of electromagnetic interferences तो electromagnetic interference हमारा driving circuit है और power circuit क्या है अगर वो रही जे पावर सर्किट थर्मल मैनेजमेंट तो इन्वर्टर डिजाइन करते इन्वर्टर कला परे से भीतर हम स्विचिंग करते जो मेथड रे से स्विचिंग कला परे बहुत गुडी पल्स इनिशिएशन जोड़ा के लोकल फास्ट क्रिएट हम जान पाते अब किसी सेटा के थोड़ा सो बहुत इंपॉर्टेंट है तो हमें किसी दिन पर काली अपने प्रोजेक्ट आईआईटी जे लीकेज मैनेजमेंट लीकेज डिटेक्शन सिस्टम यूजिंग आईओटी सेटा हम डिस्कस करछोली जे बड़ बड़ पाइप रे लीकेज जाउछ किलोमीटर 2 किलोमीटर से पाइप रे लीकेज की बाहर करेगा अब वो लोकेशन में लीकेज की डिटेक्ट सेटा प्रोजेक्ट चाहिए जनरल काम करछे तो से ऊपर जान चले सेटा पूरी इंस्टॉल करू सेठी जेतो हमर इंडक्शन मोटर 30 किलोवाट इंडक्शन मोटर जेतो हम टर्न ऑन करते सडनली वोल्टेज कम डाउन टू 180 170 अल्प समय पे वोल्टेज का आसे जोटा हम डिवाइस से कनेक्ट हेतिले लीजर द कांस्टेंट लोड तो बहुत करंट करे से डिवाइस टा फुल तो तीनटा चारटा जगह रे ए टाइप नहीं हम रहता बहुत गुडे हड़ताल कोड इन 16,000 वाटर सप्लाई है सेठी हम डिटेक्शन मैनेजमेंट करा जो समय 30 किलोवाट पंप आरंभ हुए से समय एटा में आरंभ हुए लार्ज करंट तो कितने बड़े छोटे छोटे चीज कितने इम्पैक्ट द रिसर्च टेम्पररी fundamental research more important than any kind of research. Fundamental research जेतरा करियानी सेतरा मते आपको करियानी आवश्यक। Then when my student join होत करते कि चारटा आइडेंटिटी ट्रांजैक्शन यूनिट टू गेट 7 वर्ष लगो 8 वर्ष लगो 10 वर्ष लगो 9 8 5 आइडेंटिटी ट्रांजैक्शन नो अदर चैनल unless you don't maintain the qualities, student also जिबे कोरल लोग छोटे जगह तब भी बड़ा बहुत important bidirectional power flow जोड़े के आप मेंटेन करते हैं flexible active reactive power एटा अन्ना यूनिवर्सिटी का अच्छा डेवलप करना से काम करते हैं इलेक्ट्रिक व्हीकल चार्जिंग इंफ्रास्ट्रक्चर reactive power management से करते कि ताकर हार्डवेयर नॉलेज बहुत भी नहीं केवल ताकर सुविधा सुविधा और जाती जो reactive power management बहुत इंपॉर्टेंट है जो जेतरा हम चार्जिंग करते सबोले हम रेक्टिफायर इन्वर्टर से कनेक्टेड तो reactive power management बहुत इंपॉर्टेंट है बहुत बड़ा then PV integration action करे कि PV को integrate करेगा and frequency regulation need grid अपना हमें देखिए frequency वो जेतरा टेनिसी टेक यूनिवर्सिटी के पढ़ते टेनिसी टेक्नोलॉजिकल यूनिवर्सिटी से भी मारो प्रोजेक्ट है एफनेट प्रोजेक्ट जिसमें 6टा स्टेट है Tennessee State in the middle, Mississippi, then Florida, Michigan, North Carolina, and the छोटा state है, छोटा राज्य है। ये छोटा राज्य है, minimum each छोटे राज्य है, there are 1,600 big substations। और सब substation में हम PMU frequency monitoring के इंस्टॉल है और सब जगह से frequency आसे 50.1 0.1 59.1 सब that is called AICTE network frequency monitoring network हम इंडिया का कौन है इसे frequency monitoring very big इतने complicated अब मोटे कंपनी that is Tennessee Valley Authority जोड़े के पूरा सारे पावर सप्लाई देते हैं हम ओडिशा रे के पावर सप्लाई हम ओडिशा रे छोटा पावर ओडिशा the adjustable speed drive, आपको 1 किलोवाट दरकार ମୁଁ ଦେଖିଛି ଆଲାସ୍କାରେ I have seen in Alaska and Canada, so there the snowfall there, say snowfall after snow cutting machine, जितने snow thickness थी ता अनुसार ता drive so that is called adjustable speed drive. What is the requirement? Temper stars as a kind of. अब आपने अगर देखिए आप प्रथम 100 किलो केवी डीजी आईआईटी पार्टनर है जेतोला में नॉर्मल आईआईटी पार्टनर है 100 केवी है इवन 1 किलोवाट रो अछि आप 100 किलोवाट से फ्यूल कंजम्पशन करो क्यों तापरे फर्स्ट टाइम एक सोलर प्रोजेक्ट तोयपुर विलेज रे first solar plants were adjustable speed generator developed by industrial and the integrated electric panel who designed our student design as a गाने 50 घर थे से 50 घर को तोयपुर वैशाली डिस्ट्रिक्ट रे 50 घर को adjustable the speed drive generator first time double fed induction generator used as a diesel generator जुड़ा विंड टर्बाइन जो चिता कंट्रोल करके आना देती है तो मतलब चार्ज 50 टन और सप्लाई के सोलर नॉट डीजल ये कंबाइन दैट and that is the first variable speed generator in India. So then this is the optimal is very important. So and देखिए वर्तमान the worldwide आप देखिए सब IIT बनाया charging station, government, Indian Oil, HPCL, they are sponsors. हमारा IIT में charging station है लेकिन इनकी सेलिंग किए हैं charging कोई so the charging station है it is exponentially आपको देखिए बहुत बड़ी कंपनी especially Indian Oil they actually supply the charging station and power grid is supported them and तो हमें देखिए बहुत बड़े प्रकार charging station and they are very costly charging station and the different topologies I am not going to detail एवढा तो ये रहती तर kilowatt 6.6 kilowatt and 3.6 11.5 7.5 up to 320 kilowatt you can find. So another one you can see here. This is a simple charger. Then we have grid charger directly grid is connected to the battery through this dual active bridge converter. अपना actually DC converter अपना अच्छी buck boost like that. Dual active bridge converter मतलब से DC converter किंतु हमारा converter टा 20 वोल्ट जब 12 वोल्ट बैटरी को हम 220 वोल्ट पर करेंगे अचानक हम मॉडलेस very high and it is destabilized हमारा DC converter ना किंतु हम जब dual active bridge converter यूज करेंगे ताहले 12 वोल्ट को 230 वोल्ट why there is a very high potential transformer between this the input and output that enhances the voltage. हम कौन होती दिन सारे में ये इलेक्ट्रिक ग्रिड टा और सोलर पावर टा ऐसे चार्ज होती और जो नाइट टाइम चार्ज रिक्वायर्ड और वो रिक्वायर्ड to stabilize the grid we can reconnect this cable and it can discharge or it can charge in both ways it is possible by using dual active bridge converter and mostly it is high density converter adi amaro worldwide area use hoge so we have an AC DC converter then you have to maintain the power factor AC DC converter में available है the power factor is बहुत power factor में कौन that is called utility friendly converter and the converter बनने पड़ेगा जो कि ये हमारा सेचुरेशन daughter is important, son is important, but the proper, the work model, that is not so important, but it is important. So that minimal reactive power requirement is actually transfer the energy from one source or source to another. That is minimal requirement is required to keep it. So that is why the AC/DC converter became that. Then there are also the very frequency deviation between the active power management, reactive power management. So our rating goes very high, above 100 kilowatt. छोटे छोटे चार्जर में हमें किसी देखते हैं 3.3 किलोवाट चार्जर many we have developed, किंतु उसमें ज़्यादा difficulty. Now we are designing a charger for a drone. Means in IIT Mandi they have 5 drones. Each drone required 58 ampere and 48 volt. और जितना drone करे हमारे 22,000 ampere milli ampere hour battery लगे सकते हैं। और से जितना drone का पानी jet जितना forest fire है तो सेठी jet रे पानी जाए पकाते तो जितना हम jet से लोड करी जाए जेट पानी को गए वर्तमान तक चलते जेट बड़ा पाइप चलता है सच जीवो पर वो समय रे ऊपर उठे जो 22,000 मिली एम्पियर आवर बैटरी स्टेट ऑफ द चार्ज 100 टू पूरा 10% जो ऊपर गला पर आसी जाए और तौर को आने पर और दूसरा सीधा 100% दे जाए बैटरी तो बैटरी चार्जिंग जब तक ऊपर चल जाए सेटा तो ओनली 10% एक्स्ट्रा तो ना आप तो ऊपर ऐसे डेटा बहुत डिफिकल्ट है वर्तमान हम स्टूडेंट में जाएंगे वर्तमान गोटे ड्रोन चलाएंगे so 58 एम्पीयर करंट हैंडलिंग इज वेरी डिफिकल्ट आप ऊपर को 380 एम्पीयर जीवो आ सेडी का अपना सॉकेट डिस्ट्रीब्यूट करियो रियल चैलेंज तापर बंडल ऑफ कनेक्टर दे बंडल ऑफ कनेक्टर देला पर इनर्शिया बहुत बढ़िया लोड और करंट ड्रॉप तो बहुत बढ़िया परमुटेशन कॉम्बिनेशन पर लास्ट वीक हम स्टूडेंट वाले ताकर स्टूडेंट को धरिया थे एक टेस्ट करके ओपन मोटर आज को चले पारो क्योंकि 58 एम्पीयर ईच कंडक्टर पाखे रहियो इतने हीटेड हो से कंडक्टर multi-ton conductor short. These are the lot of problems are there. Therefore, ये बहुत ही practical problems. हमें generally problem से जुड़े charger making very important. These are really tough problem. तो सेटा हमारे वर्तमान ताकर 3 जन स्टूडेंट PhD हमारे 2 जन PhD 5 जन हमारे उन्हें लागू है लेवल सेटा के सॉल्व है and we have given them 3 months time. In 3 months, that पूरा power supply, which is you can supply 380 ampere for charging the drones. सेटा वर्तमान हमारा टारगेट पे चलছে। दिन सारा डिजाइन करছো राती हेला जड़ जातछ। आउ थे नवा कंडक्टर मोडाछ आउ थे करছো। These are the challenges. Therefore, हम रिसर्च रे केबे डिसाइडेड करबाना। मैंने जितना फर्स्ट आरंभ कली मो 58 मॉस्फेट जड़ा देती तो वो गाइड में तो पहले एसपी का सर आज के लिए आईआईटी बॉम्बे आईआईटी से पहले तो छाड़ दे 58 पीएचडी कोला वाले मिसिसिपी आईजीबीटी अराउंड 60 आईजीबीटी टू से समय 15,000 इन 60 ना मुझे तापर सार पहले तो आते आवश्यकता पीएचडी तो छाड़े जा तापर सार में तो पटेल नमस्कार टेक्निकल स्विट्जरलैंड 3 जगह पर तापर मुझे जाए से देखिए आओ से पहले तापर पहले आपको भी पठे उसमें तो सब जगह पठे देते अतर हो ही नहीं 4th year अथा 4.5 year I could और हार्डवेयर चले रिसर्च इलेक्ट्रॉनिक तो बहुत गुड़े स्टूडेंट ओडिशा रिसर्च स्टूडेंट कौन हार्डवेयर mostly high density DC converter. So से जायची दी सप्ताह है दी वन मंथ तो आपण मध्ये काम प्रकार सब प्रकार हार्डवेयर আছে चार्जर वाला पड़ेगी मल्टी फेज मशीन सब हम स्टूडेंट वाले बने से हार्डवेयर ठीक है अब एटा बहुत गुडे डीसी कन्वर्टर अछि एंड दिस आर द चार्जर आपण देखिबे एटा देखिए प्लगिंग प्लग इन चार्जर एटा हमर डीसी टाइप प्लस माइनस और दिटा ये है एटा सोलर पैनल बैटरी पैक एंड ये कंट्रोल पैनल यूनिट अब एटा हमें मॉड्यूल का डिजाइन करो परफेक्ट के डिजाइन और देन प्लेसमेंट ऑफ दिस वन then we charge station and this is the dual DC converter then se converter ta hame first laboratory scale banao tapore taku hame PCB develop koribe calculate so it is so basic fundamentals then eta pura module ta vehicle saito CAN system saito tapore modify karu and hame jo vehicle design karu CAN bus CAN communication tha jota ki vehicle सब time ସେଥିରେ integrate करता तो that is why there are a lot of efficiency there this modular design modular design करो module wise हम connect करो module wise connect करले कौन हुए कहना गोटे module खराब हो जाए से just replace करते हैं therefore modular design is very important thing गोटे modular high frequency so our the basic fundamental is dual active bridge converter. Dual active bridge converter either is full bridge, half single phase full bridge, either is single phase full bridge. Our AD है ना high frequency transformer. आपको देखिए वे either operated 10 kilohertz frequency. 10 kilohertz मैंने आपको देखिए 1 kVA transformer 50 hertz इतनी बड़ा एटा 10 kVA ट्रांसफार्मर आर साइज एटा हला एडवांटेज है बेसिक ट्रांसफार्मर तो किंतु डिजाइन हमें आज पीआरई एटलीस्ट छोटा डिजाइन करला और सब डिजाइन वाला फेल एटलास्ट गोटे बीटेक पिला प्रोग्राम था से बुझातला आईआईटी ऊपर से पिलाटा खर्च पे बनेला PhD पिला बने पहले नहीं किंतु बीटेक तेरे हार्डवेयर रे आप कोई पे विद्या आई एम एक्सपर्ट वाली चलो थी ऐसे चलती हुआ अपडेट करो वही चलो तो हार्डवेयर रे नो सर्टेनिटी comes after lot of hard details तो एडी कौन हुए एडर लो फ्रीक्वेंसी टू हाई लो पावर टू हाई पावर एडर टर्न्स रेशियो अपना n number of n you can increase or decrease एडर पूरा हाई पावर को जाएगा तेरे गोटे काम हम करथिलु एडर कोन गोटे पोर्ट 1 पोर्ट 2 जिते हमर पावर ट्रांसफर हुए जो हमर गोटे सिंक टू सोर्स p is equal to v1 v2 by x sin delta the same thing is here the same equation that power की उपयोग करो a पोर्ट 2 से पोर्ट 2 केवल very simple very powerful and these are dismissing signal and these are switching logic which are details down power p1 p2 is input power input 1 power এটা হলো পোর্ট 1 এটা এটা হলো পোর্ট 2 so port 1 का power है defined is this one port 2 power and lossless system से बोले port 1 अपन देखिए जो port 1 का switching circuit is like this port the electromagnetic torque develop করছে যেটা সেটা third harmonic component আছে fifth harmonic they develop the retarding torque. So net torque is developed torque minus retarding torque. So that is like this. This is like a retarding torque in the machine. So similarly, this is the reverse power. Reverse power flow कौन करियो? When reverse power flows कौन करियो? That will create more resistance. More resistance create करियो वाले कौन करियो? That will create local hot spot quickly. That means that पानी का flow जाऊँगी मचले के कौन जो जाऊँगा चला ची तो पानी ना रोहिला तब टेक्निक करियो exactly. तेणुकरी आमर एटा तो सिमुलेशन नहीं एटा तार कंट्रोल एटा पूरा कंट्रोल लॉजिक टा देन आमर के टेक्निक यूज करो है नेगेटिव पावर को कैन रिड्यूस तो सेटा आने enlarge करेंगे आप देखिए kind of performance is not reduced. Only what we need, we have created a signal which is a quasi-square nature. তারপরে এটা আমরা দেখুন যে নেগেটিভ পাওয়ার ফ্লো ইজ রিডিউসড suppose আপনারা লং কেবল মধ্যে দেখিবে মোটর 100 কিলোওয়াট মোটরটা লং কেবল নিয়ে there will be reflective wave and সেটা আমরা কেবল দেখুন আমি দেখুছি তার সার্কিট ব্রেকারটা কাইন্ড হতে না this is very fundamental তো আমরা দেখি এটা this all analysis then simulation করে and data method compare করে ও method efficiency is very good and power transfer is very high so data method করে extended phase shift করে মেথডটা সেটা আমরা হলো পাওয়ার প্রয়োগ তারপরে সেটা আমরা মডেলিং করা যায় মডেলিং জেনারেলি সব প্রকার power converter modeling করা যায় কারণ to understand the dynamic of the system dynamic পরি আমি জানলাম যে এখন মডেলিং এর খুব এসেন্সিয়াল আর জেনারেলি মডেলিংটা আমরা এটা করে সার্কিট লেভেল দুনিয়াতে আর সবরে আমি যেটা পাওয়ার ইলেকট্রনিক সার্কিট মডেলিং করছি জেনারেলি আমি লিনিয়ারাইজ পিস স্পাইস মডেল ছোট ছোট ভেরি সিম্পল ওয়ে power electronics model is always a nonlinear circuit. That is not a linear circuit. And this power electronic circuit, I mean, at a modeling way, so it is switching function. U1 is our switching function, 1 or 0. So, it is completely equation, and it is very differential equation. More equation पूरा जानते हैं आपको कोई जरूरत then simulate model and delay circuit development very simple and then Fourier series linearized linearized analysis is very essential because non-linear technique becomes very complicated when we analyze the circuit so but the system is non-linear that is why you require the linearized system after linearizing I am not going to detail. This is the state space model and after this space model this is the observer. যেটা ওটা আমার মনে আছে বিটেক সেকেন্ড ইয়ার পর ওটা ইন্টার ইসরো আহমেদাবাদে যাইছিল সেই জন্য ଥିଲେ দাস মুক্তা বলে से 100 into 100 matrix को सेकंड देखिए सेकंड 3 by 3 matrix 100 into 100 matrix को देखिए 3 by अब all states are observable and this is the beauty of जैसे हम कहा है इलेक्ट्रिशियन हमें हमारा यदि हम कोई स्टूडेंट वेरे ऑन करो स्विच समझने डर भी देंगे हमारे इलेक्ट्रिशियन क्वारंटाइन करेंगे जीवन लेवल हाँ सारे क्वारंटाइन तो ये टाइम हमारा लो 3 by 3 matrix and then closed loop control So అందుకోసమే our system stable or robust ఉన్నాయి but disturbance create. So disturbance create करेगी ताकि हम total model बनाएंगे. So total model another existence. ये हम 3 kilowatt charger approximately design करें. ये total small scale modeling ताकि transfer function है. Transfer function stability study करें whether it is stable or not stable. Then these are the model blocks. I think we have mathematical. Then we said that the system is stable during the total state also. Then it becomes very easier for us to develop the model. And after modeling this complete control unit, and you can see that the power is going from input to output. So the power is goes and increasing, and these are the for long time simulation. You can see here the voltage is when you have very high voltage. You can see this is the power. So you can see that there is a lot of voltage variation. जैसे इनमें हमें देखिए Chinese charger मुझे 110 volt to 240 volt तक. This is what the output. This is what the very high voltage variation, and this is the power increment. This is the reference voltage, and this is the actual voltage, and this is the tracking error. And conventional they have done, but the change is very small, whereas our controller we have very large. Then EV charger, बहुत प्रकार charger, onboard charger, off-board charger. Then non-integrated, integrated with chargers single stage and dual stage charger. अपन देखिए, these are the available charger all around the world. So worldwide, एक कोई charger available है, and up to 40 kilowatt charger is available on 490, which is a large battery can be charged at 490. And there are level 1, level 2 DC level charger, AC charger, and there are, and in different countries what kind of charger they are using. And this is in our India. Okay, we are having this type of charger in India. And this is the Chinese chargers are available. The USA charger, and this is the Europe charger. And charger, first we have the EMI filter, then AC/DC, and DC/DC, then battery. So there are different configurations people have given. Based on this one, you can see this fault tolerant charger, and the totem pole, this one, and 3-phase T-type charger. It can produce 5 level output. So the harmony will be low. And this charger is very popular, and especially this is the active blue charger, and CLLC. This is LLC. Okay, this is charger. That means it is your filter and resonance, the resonance active charger. So then there are modular chargers. You have 3-phase, 3-in-1, and quad charger, and you can go up to 3 kilowatt per the level. Okay, 1 each. And this is the DAB based matrix converter. There are also integrated chargers. I told you that this is the motor, and this is from grid. It is driving the motor. When the grid is not there, the battery at the same time from and gate-to-gate design also. And this is the PAV converter, that is the model, a small signal model here. And then we have a transfer function, this one. Then this is the modeling of this PAV converter. And this is the conventional control model, you can see. And this is the proposal model. So this is a controller which we implemented, and this is the all the equations. I am not going to detail of mathematical equation. You can search clearly past all these research papers. So what is the main option here? Is that when we develop a control, so how the control can be taken, and after that we can see this is our hardware, which is 1 kilowatt charger we develop, and you can see that this is the software control system. That here in the dual loop you can have this type of the depression, the transients will come, and that transient is you can see that sudden change in the output voltage. When there is an output voltage difference, you can see that there is a lot of voltage tracking. And sudden change in the load current, suddenly you increase in the load current. So what you can see that voltage will come down. Whenever there is a load current high, then you will see that there is a voltage drop. And impedance, that is. And then sudden change in the input voltage. Input voltage variation you can do, and this will change it. So this is our operating model. You can see that this is our PAV converter, and this is the port 1, port 2, and this is the high frequency transformer. And this is the PAV converter for the PC, and these are the current and current ports. So here you can see that they are generated accordingly, and then these are the current. So we have developed this one and very easy implementation. So they are thank you.
This is up to 100 meters. This is up to 100 meters. But if you are using more than
what? And they, after taking them, they didn't pay money. They took the design they used, they got the Chinese charger, everything. 400 vehicles they said. If you got one vehicle in Vijayawada, state of whole public. So everybody is asked inside,
The same controller, you can run your 3 types of it. So I am able to do but battery manufacturing
universal level that both difficult.
universal नहीं करते but difficult हो जाता है battery because हमारे battery servicing center जो है तो हमारे different battery ऐसे पहुँचे सब तरह क्या with can रहोचे without can रहोचे then BMS भी different types of रहोचे तो यदि future में
सबके निर्णय जगह पे और 5 वर्ष होता है
साढ़े 9 नहीं
कारण जे जाडू तुम्ही स्वस्त मिळल्या चायना राहते आणि दिल्ली इफेक्ट होतो मार्केटिंग भारतरे आमचे प्रिंट मार्केट त्याच्यामुळे सुद्धा चाकरी करतली ते सगळे राशियन लोक अछन सब सामान राशियन असते आणि प्रिंट करी 3टा स्टेज टर्बाइन आले तरी छान करतात हां से 3 स्टेज टर्बाइन पे मध्ये से राशियन लोक आम्ही कोण बोलतो कॅल्क्युलेट करतो वारकर से नाही चायना जे सामान आवश्यक पुढे जहाज भरून दिल्लीने सोपिट दिल्ली अहमदाबाद एवढा सोपिट कंपनी रिस्टाम्पिंग होते
सेल भी जो है सेल स्पेसिफिकेशन सेम भी होता है 1000 सेल तो मैक्सिमम 80 70 सेल सेम स्पेसिफिकेशन आते
से सेम हमको एवढी आम्हाला जोर पर्यंत आम्हाला मल्टी सेल ॲल्युमिनियम सेल we need to develop our thing. सबको फॉर्म में समझ होते हैं बैटरी डेवलपमेंट हो गया बैटरी डेवलपमेंट हो गया ये जितनी क्वेश्चन होते हैं जितनी होगा मिशन में 200 करोड़ से आईआईटी कानपुर से प्रोफेसर एमडी बढ़िया से ये बोले कि डॉक्टर गेट पर क्लासेस से हाथ से देवे चेक तापर जब कोई टेबल Physical, they have a take time.
Cell replacement around 800 का cell आने पर मैं 120 का 120 cell same for जो same cell नॉर्मली replace कर लिया मैंने वहाँ बैटरी क्या
आई मध्य इलेक्ट्रोस्टैटिक रेजिस्टेंस जो सेल है सेटा वो सबसे सेम है आपने जो सर्किट बने थे जैसे बैलेंसिंग है ईएस इलेक्ट्रोस्टैटिक रेजिस्टेंस ईएसआर सब डिफरेंट then we have one BMS isn't working all the way.
हमें IR वाला चार्जिंग डिस्चार्जिंग को लेके
नहीं करता इधर के
इफेक्टिव होता है हां इधर IR को नहीं बोलो IR वाला पर कितने इंबैलेंस रहेगा और साइकिल वैल्यू भी कितने कमी है तो IR में चार्जिंग एंड डिस्चार्जिंग नहीं करो देन सेल वैल्यू भी मेंटेन होलो छै देन IR भी साइकिल वैल्यू भलो रहौ बैकअप भी मतलब माने इफेक्टिव होछ बट फॉर दैट थिंग आपको आने पड़छ अराउंड 800 सेल आनिले हम गोटे सेल माने बैक करि पड़ो
800
अराउंड 800 पर हमें 160 को 180 बैक माने सेल रिक्वायरमेंट होछ फॉर 180 बैक
160 सेल
160 को 180 सेल बैक तो तापे में 800 आने आई तो डिफिकल्ट
ये थर्मल स्टडी करें
थर्मल स्टडी भी होछ
mainly paid individual. That study is very important. Modeling culture. आधुनिक PMS सर्किट पर कहते हैं पूरा बोर्ड है थोड़ा टेंपरेचर से एक्चुअली ऑब्जर्व
भी अभी पसंद मार्केट चलती ठीक ठाक चलती गाइडलाइन मेंटेन करा खूब ताकि टाइम में भी
नहीं ये आगे 5 वर्ष स्टैंडर्डाइज पूरा कंप्लीट है कि फर्टिलिटी कोर्स यूज करते के सिस्टम यूज करते के द्वारा बोल that is also another same 1 kilowatt somebody use 60 volt somebody use 40
it's not difficult
किंतु बहुत डेवलप तो बहुत रिसर्च करते हैं इंडिया आप चालती किंतु मेन है अपने बैटरी
cells are obviously we are saying that we are Indian हमें हम टेक्नोलॉजी
हमारे नीचे ना चला तो आने तक
वो बिलियन हुआ डिपेंड अपॉन चाइना अदर सेल वेयर परचेजिंग दैट तो चाइना से
ये हमारा ग्लोबल खर्च है चाइना रे जो जो डिपेंड है गाड़े
अरे आसुति से कंटेनर तो चाइना है कंटेनर आउ कंटेनर आगे नहीं चाइना कंटेनर ही चाहिए
हमको ज्ञान आरंभ करेंगे वर्तमान लॉन्च डेट
पानी भी आनी आसीपर कितु कोणा बैग नौचे अमृत भी आनीपर तेणु आम उपर सब डिपेंड कर को क्रिटिसाइज करने पूर्व आम आमको आनालीसीस करा आमर आम मुहर तोड़ी मारुचे कितु आप हृदय को क्वेश्चन पचार से जहाँ कहटा भी जब कम करेंगे गोड़े धूल अंटा पड़े कितु आम करूँ फिल्म जावा खराब ए चाल जावा ये शुणिले तेणु बापा माँ को बुझा उचित कितु शाशु शशुर पाद धोना उचित निश्चित तेणु कथा हूँ कौन आम इलेक्ट्रिकाल मेकानिकाल सिविल की भूली गल एआई रोडिया मार्च तेणु से गर्वर सहकार कहली वी आर इलेक्ट्रिकाल इंजीनियर वी शुड बी प्राउड ऑफ यू बिकज ऑफ सबुठू जिनटा अल्ट्रामोडर्न जिन आरंभ होती आम ब्रांच बुझिपारे तेणु आम सब ब्रांचर इंटरव्यू बसीपर आम ब्रांचर इंटरव्यू जिते गोटे मनीष जन्म हुए 4टा स्टेप अच्छे शैशव यौवन शैशव बालक यौवन वार्धक्य तेणु आम जो सब लाइफ आम भावचे पिला बेले जो भावे मो बापा माँ ग्रेट बापा मो ग्रेट हिरो अमुक समूह जो बालक हवा आप कहीं कथा खेटी जाऊँ लाड़े तो 5% 10% ताड़े प्राप्त 16 वर्ष मित्र मित्र बाबद लाड़न पालन जो 5% बाहरी से पिला कह मो बापा हूँ ग्रेट मो बापा भाई पृथ्वी में कहीं ना आइडियाल बापा अच्छा जो 10 वर्ष ताड़ना है 15 वर्ष पर्यटन बापा माँ खेटा किसी गोटे शुणुना हाँ मो बापा किसी जान जो बाहर हो ग्रेट थिंक आइडियाल जिन हाथ में पड़े आईला 15 वर्ष 40 वर्ष जाए मो बापा किसी 40 वर्ष पर जो तुम पुओ पुआ से तुमको नात मारे से जान 40 वर्ष पर्यटन शाशु शशुर की मुठिया मार 40 वर्ष पर जिते नाती नातुणी पुओ बहु जहाँ करेंगे चिंता पड़ज बापा बर्तमान इलेक्ट्रिकाल मेकानिकाल कौन हवा सब माने ऊपर तल अच्छी बोली गोटे मनीष जो जन्म हुए कहती शिशु भगवान को रूप होते बच्चे दिल के सच्चे भगवान को रूप होते माँ पेटे जो थे ब्रह्मा विष्णु महेश्वर गो दैट इज इंडिपेंडेंट सोर्स जो बाहर को बाहर धाई माइना अच्छी पिला मुझको डॉक्टर अच्छी पिला मुझको डाक्तर अच्छी पिला ये सब जिन बोले से डिपेंडेंट सोर्स गोल्टा है ठीक डायमंड से दैट इज डिपेंडेंट सोर्स डिपेंड्स अपॉन पेरेंट्स सर डोंट माइंड It is our privilege having with you here in this occasion. पाठ तो बहुत पढ़ुचे ये जिनस आम पाइबू सर है सो सॉरी जब मोर भूल देव क्षमा कर
completeness of the human life. Rest and not food. Our human life is ahar, nidra, bhaya, vaishunamcha, eta, narana, pasubhi, samana. Dharma hi esha vishesha adhika. Dharmena hi na pasubhi. Prahlad Maharaj.
Silent.
तो कितने लोगों प्रहलाद महाराज का विषय जानते हैं हाथों को उठाओ ऐसे बोला प्रहलाद महाराज जानते हैं कितने बोला ऋतिक रोशन को जानते हैं हाथों उठाओ
ऋतिक रोशन को जानते हो
तो प्रहलाद महाराज को सुनिए कि आहार निद्रा भय वैतुर्य खाइबा शोइबा और पिला जन्म होगा और खाइबा ये चारिटा मनुष्य और पशु भितर दुटा के समान लेकिन मनुष्य जीवन में कौन अधिक धर्म ही ऐसा अधिक विषय केवल धर्म जो कि ह्यूमन बीइंग कैन अंडरस्टैंड what is good, what is bad. धर्म ही ऐसा विशेष अधिकार धर्मेण ही न पशुपति तेपरी आज आम समस्ते स्ट्रगल करते ना नहीं ये तो स्टूडेंट स्ट्रगल करके ग्रेड पाइबा आम स्ट्रगल करछे कि आम एस्टाब्लिश करबा समस्ते स्ट्रगल करछे एटा स्ट्रगल इज वे ऑफ लाइफ तो भगवत गीता रे भगवान से स्ट्रगल विषय कहते समस्ते स्ट्रगल करछे आमेले छुआ जन्म करी आमेले खेल करछे इवन पिग इंडस्ट्री छुआ जन्म करछे सीएले के खेल करछे तो हम स्ट्रगल का कारण कोन तो स्ट्रगल को हम ऐसे करते गोटे गाँव रे सर्कस आसला सर्कस रे बहुत लोग रात रे चार सब गाँव रे अनाउंस होला सर्कस 25 पैसा केते 25 पैसा तो सब गाँव लोक आसती रात दुईटा लाइन लगे दिन 9 देखा प्रथम लोकटा सर्कस टिकेट मिलला से पूरा खुशी होगी गला भितर आउ से सर्कस रूपले जड़े थरे ही देख जड़े लोक थरे देख से लोक भितर गला कहला टिकेट मिलती प्रथम फ्रंट लाइन बसला फ्रंट बसला कहला सर्कस आरंभ करो जिन आरंभ करो बोले तीन तीनटा पूरा बलवान पूरा बॉडी बिल्डर आए तार मुंडर आड़ू काटी को छाछी बाड़े ले पकाले इनके लैपटॉप कोठा मारने से उठला झाड़झुड़ी होला आ गोटे एग्जिट रे पकेले तो से उठी लगला एग्जिट रात्री दो टिकट मिलला आ फिर आज के से एते माडो से भाई को जदी बाहर उठी कोई को माने खाई तो पागल से जाई झाड़झुड़ी होला हाउ आर यू वेरी गुड एक सर्कस ने और इतने बढ़िया सर्कस मुझे केबे देखि न पूरा काको आस्ता कादर बसना बहुत सिंपल है तो दिन ऐसे आप सेकंड कपड़ा मध्य जे आइला सेकंड टिकट अछि और एक्सेप्टेड है तो आइला के बताए देखा है कि बाहर भीतर गए के भीतर बहुत दिन ऐसे आके बसले से कहले भाई आरंभ करो सर्कस हाउ से तीनटा पहलवान आए एक मारता वाले छोटा छोटा पिटले जाता आउट पूरा बेहोश है कि पानी के लिए आउट नहीं दे तो उठी धारा जुड़े गया ये ऐसा तो देखला मुझे जाए वही कि मौते माडल को ले पागल है से बने बढ़िया सर्कस आउट और देख ताको करे जरा तेते पिला तेते लोक थे आउ कैसे काई ता हमर जीवन में मने एग्जैक्टली डेली आम ये माने खाऊ बाहर जाए पचार ठीक अच्छा भाई बहुत बढ़िया है ना डेली आम माने खाऊ सब जगह से माने खाऊ किंतु सेटा है आमर जो भगवत गीता रे बोले ना प्राय बोले ना प्राय युगे ना मंद बातें जो कड़ी रे हमें बहुत लेखी आ बहुत अनएक्सपेक्टेड अन्य मान ऊपर विश्वास थाए जिन गोटे पहलवान थिला ता ना थिला बजरंगी प्रेम तो गोटे छोट कंडक्टर थिला बस रो से कंडक्टर थिला तो से पहलवान जो आसे बसियो आ करके टिकट मांगे ताकि टिकट पहले से कहलो बजरंगी पहलवान को टिकट नहीं देता पहले तो कंडक्टर जब भागया ये पैसे थोड़ा है कि मुझे गाड़ी गाड़ी हो तो पहले जो कंडक्टर थे वो वर्ष बंद जाएगी से एक्सरसाइज करे वर्ष पर पूरा बड़े बड़े लोग के आया पहले बजरंगी पहलवान ये कंडक्टर टिकट बजरंगी पहलवान पूरा पहला बजरंगी पहलवान टिकट नहीं देता ये जोड़ी रहने को काई लोग कल्याणी से पास वर्षों मध्य आमर तेणुकरी मनुष्य जीवन में बहुत इम्पोर्टेंट तेणुकरी भगवान भगवत गीता कहते कि विद्या विनय संपन्न ब्राह्मण अभिहस्ति सुनिचेन सपापित पंडिता समुदस्ते विद्या मीन्स विनय जो विद्या हो आनंद विद्या नहीं विद्या किसी विद्या विनय संपन्न ब्राह्मण अभिहस्ति सुनिचेन सपापित पंडिता समुदस्ते जो पंडित तापाई ना के बड़ के छोट के पियन के ऑफिसर के आईएएस के राज्यमंत्री एवरीबॉडी आर इक्वल दैट इज और सेकंड क्या और दारेशु मात्र और प्रोटेस्ट दोस्तों और जिन सब केवल हमें अच्छा करे नहीं भगवान का प्रेम भूमिका मां वर्षों पूरे से whatever we get by the providence of the Lord we should be satisfied with that and that is the real and what is that then for others wife this is the biggest education Bharat has given as body education as गाँव में जाइए कहीं पे भी जाइए आज कोई ऐसे हम लोग को ऐसा कि नाम से जरूर करते हैं पहला दिन में 25 थप्पड़ लगाए 15 थप्पड़ से पूरा पता चल गया कि इसने किया आजकल वो रास्ते पे आते हैं कानून पढ़ने इसलिए मुद्दों को नहीं पीटने से सामने नहीं निकलेगा तो लोग कभी ऐसे ही हाल है दैट इज व्हाई वी ऑल शुड नो दैट मनुष्य जीवन का क्या सर्वधर्मान प्रत्यज्य नाम एकम शरणं व्रज अहम कौन सबरे तात्पर्य मुख्य शरण भगवान चैतन्य महाप्रभु 500 वर्ष पूर्व बहुत सिंपल प्रोसेस है भगवान जानिया देखते हरे कृष्णा 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 हरे 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 राम 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 हरे कौन मंत्र समझ कोई करे मसे पहले समझ को हरे कृष्णा साइड है से बोलो जो हरे कृष्णा 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 हरे 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 राम 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 हरे हरे चैतन्य महाप्रभु कीर्तन देते स्पेशली ओडिशा बेंगल আমি সম্বন্ধে এটা করে আপনি দেখিবে আসল করে কিছু পার্টিকুলার হবে আমি গাইড করে হ্যাঁ
AICTE-VAANI program, like to regarding the smart infrastructure and its impact, how overall system big impact is there and followed by remedial measure. So, first we have to understand. We have to understand first. All of you, if I understand, you are from power system background, electrical engineering, right? All of you are from electrical engineering. Anyone from other branch? Okay, fine. So, as far as this electrical engineering, the umbrella is concerned, we think that okay, I am a man of power system, I am a man of power electronics, I am a man of control system, but that is in this modern era of the integrated power network infrastructure, these three are not usually decoupled. Try to understand. Whether you are from the background of power electronics, whether you are a background from power system or control system, all the interdisciplinary impact as far as the overall integrated power network infrastructure is concerned, it is indispensable and it is pertinent. Right? So, if I start from the beginning, so power network infrastructure would be normal transmission, distribution and integrated transmission distribution network. Student, now how this power network, if you take about the power network infrastructure, how does it look like? Starting from your, suppose you are taking it a one-line diagram of a power network. So from the normal, so how you what are the integrated components of that? You can take normal your generator, your transformer, your transmission line, and the different groups. So when we are talking about a decision support for a power network, what you are supposed to do? What you are, just let me ask you something, then you will stand. What you are supposed, subjected to the occurrence of fault, you are supposed to make a decision support. So for that, what you are supposed to do? That means you are supposed to find out a protective action subjected to the occurrence of fault. So what you are supposed to do? This is one aspect, that is your fault and the remedial action. So what you are supposed to do? Any one of you? So first of all, let us tell the generator, the dynamics of the generator, the transformer dynamics, the transmission line, the frequency sensitive models or the version model, and the load dynamics are all the integrated network infrastructure. Now the question is that you are supposed to make a decision support subjected to the occurrence of the fault. So the fault is coming under the faster time scale. Try to understand. You have a time scale of operation. That is I just told you something before we start. So subjected to the occurrence of fault, I was telling that the decision support is supposed to be made. How the decision support will, that means your protection action needs to be activated. So for that, what you are supposed to do? Any one of you? Try to understand your integrated power network as a whole in the total time scale of operation.
किछिटा स्लो टाइम स्केल अछि, किछिटा मीडियम टाइम स्केल एंड किछिटा फास्टर टाइम स्केल is there, right? So faster time scale of operation rate, fault when it is there, it will come in the faster time scale. So all the associated states and the formulation of the dynamics what you are supposed to make, corresponding to that you are supposed to make the decision support that which is coming in the faster time scale that has to be taken into the considerations. Suppose the generator dynamics. It is inherently it is a complicated system because you have to take a spatio-temporal distribution of the flux where your inductance is a function of your space and time, and correspondingly some correlation factor is also there which aggravates the system equation, and there some slow dynamics are there and some faster dynamics. किछिटा स्लो डायनामिक्स अछि, किछिटा फास्टर डायनामिक्स। तेणु गोटे आमर गोटे इंटर नेटवर्क रे तो गोटे जनरेटर नै, इट इज अ क्लस्टर ऑफ जनरेटर्स, all the segregated generate different generators. Suppose you are now talking about the classical network, so how you go for the clustering of that? Your generator, you are suppose you are ideally 39 boxes where you are 10 generators are there. So how you cluster these certain generators which will make me a coherent, a particular zone where I am supposed to initiate my protection action. That means I have to take the identical generator into the account which will take subjected to any type of fault or what your swing action, and what the subjected to any perturbation, it will exhibit an identical view. So we will plot those into a single cluster, and accordingly, because when you are going, all of you know about the swing equation. What is the swing equation? Your n d square factor d square equals to Pm minus of P max sin P sin delta. Can you tell this Pm is inherently constant? What does it mean? Because it is coming under turbine and the governor loop, it is coming under the mechanical time constant. And when you are deciding the time scale of operation, where you are supposed to find out the decision support, say time at that time of instant, this slow dynamics has to be inherently neglected. That means any perturbation of PA, you are not taking into the consideration. So PA is inherently constant. So with that doesn't mean that any perturbation on the PA, whatever you are taking in that time scale, it is completely redundant. So when you are taking this delta as a function of time, this is a non-linear, non-homogeneous equation. Try to understand. This is a non-linear and non-homogeneous equation because you are getting a function sin delta. It will expand about an operating point. That is delta 0 minus of delta p by 3 factorial plus so on. And this is inherently a second order non-homogeneous non-linear equation. And you cannot find out the solution. So you go for the two approaches. One is the small signal analysis. That means perturbation about the operating point going into the nearest neighborhood. Say neighborhood bhitare ame dekhiba, say subjected to choto excursion it is coming in the pro-post disturbance equilibrium whether it is stable or not. That is the objective, right? So it is generator, transformer, transmission line as a whole. When I am taking all this integrated network, it will be a highly nonlinear and higher differential equation. So it will have a, when you are talking about the control, when you are talking about the stability, try to understand the stability. When you are talking about the protection, in this nonlinear equation, the decision support for protection, the control action within the stipulated time, it is inherently difficult. So So for that, what was the roadmap? It was a classical system with the initially inertia-based source, right? So in the due course of time, what happened? How it went down? There the renewable penetrations came into the air, within the due course of time, where the inertia factor is a critical issue that needs to be discussed, right? So the inertia factor comes with respect to the renewable energy penetrations. So it is not only the renewable energy, the storage system as well. Storage system as well, the integration of the same and the electric vehicle. So these are all penetration. ଯେତେବେଳେ এই ସବୁ penetration ହେଲା, এটা grid ରେ impact କରୁଛି. The question is that you have to understand the complex dynamics, try to understand the stochasticity and the inherent intermittency of the renewable resources is very important, because when we are talking about the solar, your solar insulation, temperatures, your maximum power point tracking, whatever you are talking about in between, it is an inherent stochastic and intermittent source. So we have to control, you have to have some control action in order to have a feasible penetration in the grid. Even grid impact of the study collaboration, wind and solar, तारो dynamics को नहीं तारो penetration level, how much it will be there, so that it will be feasible. Okay, this will have more a detrimental impact on the grid. That you have to understand. So एक वाला बोलेला renewable energy penetration. तापर आसला सब renewable energy खाली penetration हेले सब करे वर्तमान. Now the concept of smart grid comes into the picture. So the smart grid is what? It is the amalgamation and the augmentation of the infrastructure with respect to the bidirectional power flow, communication proper communication protocol and compliant, and corresponding to that, how your smart grid is supposed to behave in a transmission level, in a distribution level, in a micro level. Right? So that you have to understand. So again, electric vehicle. So that is now a tremendous, this is a major cost. The electric vehicle asila pore basically what is storage system is. Then we use stochasticity and intermittency of the renewable source. Each electric vehicle charging station and the battery will it come in a certain way that okay the stability is considerably enhanced. So that you have to study, right? So as far as the electric vehicle, the fast your operations, probably Professor Behra, he has already described also. I do not go in details. I will go for all the signal processing, your control aspect, and your protection aspect, behavior subjected to that, and the power electronics aspect probably we have discussed extensively, so it should not be reiterated. So it is, so basically the electric motor, instead of the IC that generates power with a mix of fuel and gas, and try to understand this is a holistic approach where you have to go for with respect to the pollution, global warming, and different with respect to that we have to make the corresponding action. So how this evolution of the EV, you have already the different type of vehicles, that is pure electric vehicle, pure battery, and the hybrid electric vehicle, plug-in electric vehicle, and the fuel cell. These are all the variants. Try to understand. So these are also you are all aware of. So how is, so that is the ministry. This was long back it was taken. It is not updated. Now we have to go for a tremendous. So you have a 30% electric vehicle on the Indian road by 2002. P0, and again it might go in a big way. So, try to understand electric vehicle penetration collaborate, impact को aspect as battery, your dual active converter you might be knowing, DAC. Converter control. First is one is the converter control. Your storage system, how it impacts the small signal analysis. So can you have probably done some work on small signal analysis? Can you tell me storage system, how it will impact in the small signal analysis? Just you can answer some probably small signal analysis is a common question. But how the storage system, it will come in a way, how it will, what it will be impact in the small signal analysis. Small signal analysis, what does it imply? Inertia is a respect to respect to enable inertia also the inertia factor is there. Understand? There is two aspects. One is stored. Let's suppose that is one thing. One is called state space model. Second one is data driven model. You have to understand from the basic because the people used to tell a lot of things without understanding. So what do we mean by the state space model and what do we mean by the data driven model? The state space model, that means you have the adequate knowledge about the model of the system. And if you linearize means for you have a Taylor series expansion, where function is a continuous, and correspondingly you are operating about the nominal point, and you are expanding it, and you are discarding the higher terms. Because these higher terms doesn't have a significant impact on the decisions of it. Let us understand like this. So what is the expansion of fx? F of n x minus x0 whole to the power n by n factorial summation from 0 to infinite. So x0 is the initial operating point. So जेकोनोसी गोटे आमे जो प्रथम रो कहबी जनरेटर ट्रांसफार्मर ट्रांसमिशन लाइन इन कैस्केड तो गोटे स्टेट स्पेस फॉर्मुलेशन कली जो कि taking the state also because the choice of state is not also unique. I have to take the state in a such a way that it will interpret the total system behavior. Okay, so state space approach re mu jota first ro x dot is equal to x plus b where x is the vector. I formulated the small signal analysis. You have to go for the eigenvalue, eigenvectors and the participation factor and the sensitivity to that. That is the mode of oscillations. Mode of oscillation. That means whatever the mode is coming, subjected to the perturbation, that trajectory. Trajectory means a path. That trajectory you have to understand. To see mode of oscillation that oscillate, our storage system ta केमिति गोटे mode of oscillation मतलब suppose गोटे node जेमति आमे गोटे normal control system काम करछे whether the roots are at the imaginary axis, whether it is in the left half of the S-plane, whether it is in the right half, or correspondingly you are getting a time domain response for that. So this storage system का हमारा small signal analysis रे different modes से केमिति how it will come and how this will impact my small signal stability, right? So again, challenge with the EV, another is the harmonics. Try to understand. You are all our IEEE 519 standard. The power quality disturbance. IEEE 519 standard. What voltage swell, sag, momentary notch, and all. So people in the power electronics area basically they design the active power filter, and correspondingly the filter design. And the stability has to be ensured. And again in the power system domain, what we do, we go for the classification of the different systems. So for the classification objective, we have to select the proper features and you have to map these features to the higher dimensional space. That means whether it is a swell, whether it is a sand, whether it is a momentary interruption, these are all clusters. So the cluster has to be mapped to a higher dimensional plane. So there, that means the correlation function, whatever you are supposed to initiate, for that, the swell, sag, momentary interruption and all the factors has to be properly distinguished. Again, for subjected to this harmonics, there is a perennial problem for the protection. Because I told you the phasor measurement unit PMU plays an important role as far as the visibility of the grid is concerned. Because when you are introspecting the entire power network infrastructure, there with respect to the optimal location of the PMU, you are introspecting the behavior of the grid. Right? So when you are introspecting the same, there the numerical relay comes into the picture. So the numerical relay, when it comes to the picture, it extracts the fundamental components out of discrete Fourier transform with the full cycle DFT, half cycle DFT and fractional cycle DFT with the trade-off of selectivity and sensitivity and the type of operation. With the trade-off between selectivity, sensitivity and type of operation. Right? So try to understand, because when you are mapping, when you are taking a signal, signal is composed of what? It is first is what? Signal no program display kariba. Signal no pratham part kote habo DC offset. First one is DC offset. Second one is harmonic components. Third one is interharmonics. In the inter and any type of other sudden notes or whatever it comes into. And try to understand this DC offset is a perennial problem for the fundamental phasor extraction. Unless we design a proper filter to diminish this DC offset, your proper fundamental phasor extraction will not be accomplished. So for that, and it is very difficult to have a proper matching of X-Y-R ratio. It is very difficult to make a proper matching of X-Y-R ratio. So for that, what we do, we go for different techniques. One is RLS technique, recursive least square. Another is weighted least square, where you go for a over-defined equations, because I told you from the beginning, power system is inherently complex, where you are getting X is equal to B. Suppose you are X is equal to B. A you are getting X is a vector and B. So comfortably you will make X is equal to A inverse B. But is it the real case when the number of variables and number of simultaneous equation is less than the number of variables? Is X is equal to A inverse B? Anyone of you? No. You have to go for statistical sense estimates. Ax is equal to B, you cannot take x is equal to x inverse B. That is the pseudo inverse. Pseudo inverse in a least square sense. That means I am taking signal statistics, co-catenation with the noise statistics. Try to understand. That means noise statistics, when you take, you are usually take the Gaussian noise with the probability distribution cos, and where your square of the error has to be minimized with respect to a state. Though of E transpose of E of differentiate with respect to x is equated to 0. That is x hat is equal to A transpose, A inverse of A transpose. So for that, so what you are doing? So I told you for the this in the so fundamental phasor and the estimation is accomplished. Now this is the how to I am going to so that it in a sequential manner it will be there. Therefore, I am taking some time. So from this, when you make it, I told you the signal is there, again noise will come. How the noise will come? What is the practical sense of noise? How the noise will come in this integrated power network infrastructure. Analog to digital conversions, quantization, error, bit overflow, and these are all noise statistics co-catenated with the signal statistics. That has to be taken into the consideration. In the joint probability distribution curve with the expectation operator. Right? So for that, when you make the sense, so thanks. So for instance, this carbon filter, this is a very prominent filter for the recursive estimation. That is the optimal estimator design. So with the EV loads, when you are going for, because the charging and discharging, when you are going for this charging and discharging, so there the load pattern, load estimation is important. So there the signal statistics with noise statistics has to be taken into the consideration. Another is battery management system. Probably you have done BMS, you have covered, it might be covered. BMS. In the BMS, there are three structures. One is state of charge, state of health, SOC estimations, the remaining charge of the battery. Again the RLU, remaining life unit, RLU. Right? So they are all these recursive estimations plays a strong candidate for the same. It is the optimal estimator with, for instance, the carbon filter, I told you. So signal statistics and noise statistics with the covariance matrix with the expectation operator you have to take, and correspondingly the estimation has to be accomplished. And track constant here you need not go for the DC offset elements. Where in the DFT there is the spectral leakage and analysis. There you, unless you go for, you eliminate this DC offset, this phasor estimation will be incorrect. Right? So harmonic issue is also important. So this is the smart, you see the smart system with the EVs. Here the PMU, your smart meters, your home monitoring system. Try to understand. We have different communication protocols. IEEE 37.138, IEC 61850. Whose message, sample values, all the communication protocol and its complaint. आमे जेतिकी communication infrastructure होउछ सेटा कोन tolerable latency आउ tolerable limit भितरे communication infrastructure properly carries the, that is the packet loss, packet drop, dropout, all the packets. So that has to be taken into the consideration, and try to understand this PMU has a visibility of the grid. PMU 60 frames per second in a SCADA, that is a static state estimation. Your PMU will go for the dynamic state estimation, 60 frames per second. On contrary to SCADA, it is just like a MRI and your CT scan. So try to understand your MRI to see the Tesla and your penetration level in the complex biological system, how it penetrates. Right? So 60 frames per second, what does it mean? When I am making this phasor estimation by the time, when I am updating with respect to the time scan, because again all my phasor is varying with respect to time, and when I am making it in the small time scale, that has to be, when I am updating the phasors, in that instant, this is almost constant. This is in the quasi-steady state. You can tell that is in the quasi-steady state. Are you getting the point? So that means it is in the quasi-steady state. So this PMU, and on contrary again the smart meters, your PD charging stations. So अभी तो इतना सब कुछ है, तो control action भी है. Control means what? Control एक वार्ड में control बोलने में क्या है? Whether it is a biological system, whether it is a electrical system, mechanical system, electromechanical system. Control means you are going for you are tracking the reference or any perturbation. Again, it is your control signal is able to track its your reference within your whatever your tolerable error that is coming. So try to understand. Here, when you are talking about control, there is still two things. One is robust control, another is optimal. Robust means there are a lot of parametric uncertainties. ये जो EV इंफ्रास्ट्रक्चर आप बोल रहे हैं ना, कभी जा रहे हैं, arrival time, your ideal state of the EV, again the departure from the source to destinations. These are all unstructured dynamics in the system, right? So ये जो unstructured dynamics है, इसको टोटल लेके हमने मॉडल करके कंट्रोल एक्शन को हम ऐसे करेंगे, we will do it in a such a way that it will reject my disturbance and my within that bandwidth it will exhibit the satisfactory response. It is a trade-off. Try to understand. S2, S infinity, mixed S2, S infinity. So that means these are all model based. But however it is robust. It is duly taking care of all the parametric uncertainties. On contrary, when you are taking a non-linear system, okay, I am not sacrificing about this operating point. Fine. Design the surface. Design a switching surface. Less scattering phenomena. And accordingly make the control action. Right? So they are sliding more, robust, backstepping. There are a lot of robust control in the non-linear senses also. Right? So you have the what? So ये उसको बोलने का कारण ये है इसमें कौन-सी ये जो कन्वर्टर कंट्रोल का हमें सपोज बूस्ट कन्वर्टर we are going for a state space average model, right? With the on state and off state exert is going to be your D and 1 minus D and correspondingly complementary sensitivity also very quality. The issue is that within the closed loop it is stable or not. We are only doing the overwork and the parameter, but that is not always accurate. Right? You have to go for all the uncertainty associated with respect to that. And within that uncertainty, whether in that bandwidth it is exhibiting a satisfactory response. That is the point. Evolving, another is the signal processing. I told you from the beginning, there are two things: signal statistics, introspection of the signal. That is very important. Whether it is in a one-dimensional space or a two-dimensional. Two-dimensional means time and frequency. You know the reason for uncertainty principle: delta x into delta b greater than equals to Planck's constant. Right? That means uncertainty in the momentum and uncertainty in the position we are taking around. So now the question is that at the point of coupling, I am retrieving the signal. I don't know much about the signal. It may be a high impedance fault. It may be a certain, even a steady state current and high impedance, they are analogous. It is very difficult part of me to discriminate about this. So for that, मुझे अगर मदद की बहुत बार impedance fault आप steady state करने जिधर करने अलगा करेंगे बहुत difficult इतने सहज हो कहीं की सहज हो because you have to introspect the signal characteristics को introspect करोगे that means first Initially, time resolution is sacrificed by the frequency resolution and vice versa. I told you, uncertainty in the momentum and uncertainty in the position is greater than equal to the Planck's constant. Analogous to that, time resolution को sacrifice करके वो frequency resolution देखेंगे, किंबा frequency resolution को sacrifice करके वो time resolution पास करेंगे। लेकिन जो non-stationary signal को जो देखें, non-stationary means your signal तो एक non-stationary signal का analysis ମୁଁ କରିବି जो signal में wavelength कौन पाएगा thanks to Ravi Polkar and other related families that told okay let the signal discontinuity be mapped into time frequency plane instead of a normal time. Time series में कौन कौन सी Fourier series, auto regressive moving average, R-max, all are time series. But time series is not a correct indicator of the signal discontinuity reflection. Try to understand. सिर्फ ताकि time frequency map को बोली time frequency map में signal statistics the signal of discontinuity सेटा correspondingly both dimension में देखिए that means time resolution यदि कम रहेगा frequency resolution अधिका किंबा frequency resolution कम रहेगा time resolution सेटा एक window है that is called sliding window that means I am taking the signal in a sufficient time frame in order to have a consistency in the decision. Consistent in the decision means suppose I am taking a full cycle data window with the overlapping edge. That means within the consecutive data window I am supposed to make a proper decision. Try to understand. So, then settle कौन है मतलब जब कोई छोटे suppose excessive inverse by transformer your energization of the transformer connecting the renewable source. These are all evolving. Evolving fault means the simultaneous fault. गोटे fault sorry नहीं, आउ गोटे fault आसेगा. Same time में discriminate करना आउट नहीं. What fault is not complete in the duration of that, another fault gets in. Ultimate is my decision support I have to see, and within that the stipulated protection action, stipulated control action needs to be initiated. But my objective get defeated. Now my objective get defeated. I am not getting the proper formulation of the same. So you see here, signal fast oscillation of the slow and fast, high frequency and the instinctive modes components. ये सब EV charging load पे everything will come into the pictures, right? So again it is further going for the empirical mode decompositions. Okay, so this is different components with a different frequency level that you take into the consideration with respect to the residue. तापर होता है residue formulation. So try to understand. Signal is composed of your slow and fast. Then it is decomposed into the various level, and my residue is there. And my objective is that the signal characteristics should not get lost. Signal characteristics not get lost. You might be knowing better in the Nyquist criteria. If the omega is greater than equals to y sub omega n, right? So there are different norms and try to understand. When you are going for this is your second norm and your analytical functions. Your function should be analytic. At least your Cauchy Riemann condition should be there. And ये सब चीजें तो mathematical aspect है, but these are all practical aspects. ये सब IEEE 39% of the EV charging station are going to all the signal that is coming in non-stationary place. I have to detect the fault in that. So you have to be strong in the mathematics with the physical same realization. It will not be solely in the mathematical sense only you get. Khali mathematics ko level. You have to be strong in mathematics. At the same time, the physical realization is also indispensable. Right? Second way of परिहार. The process for detection and classification. Try to understand. When we go for the models of the relay, there are three things. One is detection, classification, latency control with the issuance of the trade signal to the operator. So, for the same, when you go for this, we go for the orthogonal. Orthogonal करले कौन हो? जेकोसी गोटे you might be calling the vector calculus. Orthogonal decoupling we are doing in the power system domain also. We are going for the coordinate transformations. ABC to DQ, DQ to ABC, alpha beta transform your static frame to rotating frames. ये सब कहीं करो. Why you are doing so? Why you are doing so? Transformation क्यों जरूरत है? Coordinate system transformation why it is in all in a power system in power electronics everywhere you are doing. Coupling component will be, it is difficult to realize. Some linear invariant force will be manifested, and corresponding to that, I can make a governing equation of multivariate functions. I can formulate the governing equation of multivariate functions. Right? Yes, for normal experimental, these are long back in the MNIT. We use the converter, big side converters, and 5 level inverters are the gate. So these are all experimental setups. And you see here the different transformations with respect to your Q-axis control, D-axis control, and other. And try to understand here now, as you told here. One thing with respect to the EV penetration and all the renewable, there is one called virtual inertia control. Virtual inertia control for that. Okay. So that means you have to mimic, first of all you have to estimate the inertia of the system. And estimating the inertia of the system is not easy. You have to go for lot of ROCF. Basically the generation demand dispatch will manifest the frequency. But the inertia estimation, it is not easy. You have to go for the introspection of the entire power network in order to estimate the inertia of the system by virtue of the visibility of the grid by phasor measurement units. So, in that sense, if you make, so these are all the reference to grid side control, your rotor side control, your DC link control, and corresponding whether you go for a FPGA or ESP. And any one of you, can you just tell me when you are going for a real-time control? These are not point of interest. Can you tell me? Suppose you are doing RPDS, probably in your institute some real-time simulators are there. Whatever. You are designing a real-time control. What you are supposed to do? Can you tell me how you are designing a control? Whatever you know, you tell. Then I will answer. So try to understand that the differential equation is converted to difference equations. Set of difference equations in an electromagnetic transient package. वो पोलैरिटी हो कि RPDS हो तो type of all of you are using. Within that, you have to understand in that small time scale, when I am taking this generator dynamics and formulating my difference equation, my original characteristics is not lost. Are you getting my point? Again, when you are formulating the linear time varying equations to linear time invariant forms, so the stochastic stochastic difference equation has to be perfect. Stochastic, that means it is not deterministic in nature. It is inherently stochastic. And difference equation में क्या कर रहे हैं? कंट्रोल सिस्टम में 0 और 1 you are taking, right? You are taking now normal disturbance unless the conversion process is over. It is just taking the precedent state and the corresponding your action is made in accordance with that. So correspondingly is real-time controller bandwidth, controller step size, and the physical model step size has to be synchronized. Can you understand? So unless this is not synchronized, so when we go, I will send a command. Move a command pattern. Move a command pattern. Say command ताले आसिबो एतरे ताले सेटा ताले मोर अच्छा ताले आमे जेकोनसी गोटे कॉल नबा किंबा जेकोनसी सिग्नल रो कैरेक्टरिस्टिक को आमे डिटरमिन करबा प्रथमे आगे सिग्नल ताको हम अवलोकन करिया पड़िबो सिग्नल रो प्रकृतिटा कोन ए सिग्नल रो प्रकृतिटा को हमें हमें कौन करेगा ए सिग्नल रो डिफरेंट विभिन्न डिस्कंटिन्यूटी जो सब अछि से डिस्कंटिन्यूटी जानना में हमें अति एडवांस सिग्नल प्रोसेसिंग रो विभिन्न प्रकार विभिन्न एल्गोरिथम सब अछि हमें ताको अप्लाई करिया में हमें चेष्टा करिया हला ताले सेति पई हमर विभिन्न प्रकार टाइम सीरीज रो मॉडल अछि हमें प्रथमे हमें टाइम सीरीज रो हमें प्रथमे फोरियर सीरीज को नेकी हमें सिग्नल रिप्रेजेंटेशन एमिति करिबा से जो इंटीग्रेटेड नेटवर्क रो जो तार प्रकृत बिहेवियर सेतिरे प्रतिफलित होई से जगह रे सेठी प्रकृत रे प्रतिफलित होई तेनु सेति पे हमें कोन करिबा से सिग्नल रो जेकोसी हमर मानकर इम्पल्स रहला किबा जेकोसी फॉल्ट देला ताकू हमें विभिन्न विश्लेषण करिया पई हमें वेबलेट टेक्निक एज ट्रांसफॉर्म टेक्निक हमें विभिन्न प्रकार टेक्निक रे हमें ताकू अवलंबन करी तार हमें जानि परिबा को जगह रे एक्चुअली फॉल्ट अछि किबा से भई अलगा किछि डिस्टरबेंस से जगह रे अछि ଏବଂ से जगह रे अन्य किछि डिस्टरबेंस जदि अछि ताकू हमें एथु पृथक करिया पई हमें कोन करबा एथु पृथक करिया पई से को हमें विभिन्न प्रकार ताकू हाई डायमेंशनल स्पेस रे से जो विभिन्न प्रकार फीचर आसीबो से फीचर गुडा को नेकी हमें गोटे ऑब्जेक्टिव फंक्शन फॉर्मुलेट करबा से जो ऑब्जेक्टिव फंक्शन विभिन्न प्रकार इक्वालिटी कांस्टेंट एवं इनइक्वालिटी कांस्टेंट रे सेटा प्रतिचालित हो एवं सेतिरे हमें एमिति देखिबा से डिसीजन वेरिएबल रे हमें आर डिसीजन सपोर्ट होआ पई हमें सक्षम हो तापरे ए कंट्रोल एक्शन पई हमें अति जो रोबस्ट कंट्रोल जोटा करिबा जोटा की दी प्रकार जोटा मॉडल ऊपर आधारित किबा बिना मॉडल खाली डाटा को नहीं हमें ताकू बन करेगा एवं मॉडल ऊपर जोटा आधारित हो मॉडल का करिया पे हमें कौन करेगा सब को लिनियराइज करके तार स्टेट स्पेस रो फॉर्मुलेशन ताकू हमें स्टेट स्पेस रे फॉर्मुलेट करबा एवं फॉर्मुलेट करके देखिबा सेते को गुडा तार इंपोर्टेंट स्टेट सब आसुची these are all related to smart charging power systems.
We are not getting how it is related.
Just I will come to that because this first is the EV charging station. This एमिति हमारा ये इम्पैक्ट हो सकता है। तापर एक हम लोग ये भी हो सकता है ये भी माइक्रो स्मार्ट मीटर
हमारा सर्विस जो impact का what are the issues, what are the challenges, and what we can work, what we can contribute on that. That will be okay in that way.
Okay, that is there, but these are all related to understand. Data task है चार्जिंग सेक्टर में इंटरनेट को सेक्टर लोड हमने स्किल्स से चीजें को आ रहे हैं माने बी चार्जिंग स्टेशन ରହିଲା बैकग्राउंड तापर हमरो पावर सर्किट हमरे चार्जिंग डिस्चार्जिंग रे पावर तमार गोटे कोन होते
ଆମର କେବଳ ଚାର୍ଜିଂ ଡିସ୍ଚାର୍ଜିଂ କଲେ ପାୱାର କନେକ୍ଟ ଇନଷ୍ଟଲେସନ ନା କିଛି ଇନଭର୍ଟର ସାଇଡରେ ଫଲ୍ଟ ହେଲେ
इन्वर्टर साइड रो फॉल्ट संगे एटा भी आउट अदर बट से फॉल्ट को भी गोटे वन ऑफ द डिस्टर्बेंस सेटा हार्मोनी में को एटा चार्जिंग डिस्चार्जिंग मार्को भी आउट सेटा हम क्लासिक रे करे एटा हम जानि परे माने एटा चार्जिंग डिस्चार्जिंग रो से हां सेटा दिस आर ऑल रिलेटेड ए जो जिनिस का को सेटा बेस दिस बेस ए बेस का सब से रिलेटेड है तो सेट को तुम्हें डिराइव कर पाएगा और later on you can ask I will tell you how it is just it is related to that topic only it is not diverted from the okay thank you okay so I will go you are telling that I am going in that sense that will be better देखो दैट EV फ्रीक्वेंसी रेस्पॉन्स राइट तो फ्रीक्वेंसी रेस्पॉन्स रे हम कौन करछो सब गुडा का स्टोरेज सिस्टम और नॉर्मल सोवेला फ्यूल सेल EV वेट EV चार्जिंग DC टू AC इन्वर्टर एक्टिव पावर ट्रांसमिटेड एट द पावर ऑफ कॉमन कॉपलिंग एंड दिस इज द पावर ऑफ फीडर राइट तो करेस्पोंडिंगली एटा को हमें नवा एटा रे गुटेला एठी जो कौन अछि योर EV अछि वेट अछि स्टोरेज सिस्टम अछि एटरे होछि जे माइक्रो ग्रिड रो नॉर्मल फ्रीक्वेंसी कंट्रोल का हमें करछे दैट इज अ टिपिकल ग्राफ दैट इज द ग्राफ नेटवर्क तेनु ग्राफ नेटवर्क हमें जे तारा करबा तारा जस्ट मिनट हियर यू कैन सी दिस इज नॉर्मल लोड फ्रीक्वेंसी कंट्रोल ऑफ ए नॉर्मल पावर नेटवर्क इंफ्रास्ट्रक्चर जते कोन करछे सबुड काम गोटे एजेंट करछे EV चार्जिंग स्टेशन इज आल्सो एजेंट सेतोले जेतोले चार्ज कला देयर इज टू मोड ऑफ ऑपरेशन वन इज vehicle to grid another is grid to grid ठीक है तो वर्तमान में जो लोड फ्रीक्वेंसी कंट्रोल है कोटा केतरा लोड अछि आमने लोड साथे प्रथम पावर सिस्टम मूवमेंट पावर के तीन लोड अछि प्राइमरी सेकेंडरी एंड सेकेंडरी एंड टर्शियरी तो सही जगह रे ये जो EV चार्जिंग स्टेशन एटा को हमें कौन करले पार्टिसिपेशन ऑफ प्लगिंग इलेक्ट्रिकली इन द लो फ्रीक्वेंसी राइट तो सेटिंग से कौन करियो से एजेंट को कॉन्फ़िगर करियो आ से पूरा कॉमन कॉन्सेंसस से मैनिफेस्ट करियो सबुडा एजेंट माने मोर फ्यूल सेल मोर सोलर जनरेशन मोर विंड सबुडा इज वन ऑफ द ऑल आर एजेंट्स तो ये जो फ्रीक्वेंसी कंट्रोल लूप रे नॉनलीनियरिटी का आपने इतना होने फास्टर लूप तो सेटा लीनियराइज करके फास्टर सिस्टम में आगे तक नेला पर से कोन होची तो सेटा को हमरा एटा होची दिस इज द प्लग इन इलेक्ट्रिक व्हीकल राइट तो ए इलेक्ट्रिक व्हीकल रा एटा सब गुडा PV बैटरी माइक्रो ग्रिड एंड डिसेंट्रलाइज्ड मल्टी एजेंट सिस्टम प्लग इन इलेक्ट्रिक व्हीकल PV सब गुडा का एजेंट नहीं से ଗୋଟେ common consensus create that means these agents will interact with each other and our frequency escalation माने कोन generation of demand रा mismatch को ଗୋଟେ inertia based response तेनो एक में हमर चार्जिंग डिस्चार्जिंग में हमें एटा कोन फास्टर सिस्टम में हम रिप्रेजेंट कर तेनो सबुडा को ओवरऑल डायनामिक्स को लेके क्लोज नहीं सेटा हम फ्रीक्वेंसी कंट्रोल मैकेनिज्म का हम ओके फिर second house that is the one of the that is the one is the consensus layer and the multi-agent layer and it is different layer to layer communications. Layer to layer तारो communication होता है. हाँ. Yes. हाँ. Ideal state that will come in ideal state. Exactly. You have to take all the parameters and you have to make the corresponding states there. So number of in separate go to सब एजेंट का अलग अलग configuration. Overall system analysis के लिए क्या होगा? वर्तमान में एक हम point of common property के लिए कॉन्ट्रैक्ट सेटा overall बात करते हैं. हाँ सेटी pieces रू सेटा को कितने दो कितनी power extracted हो कितनी power जाऊँगी
because of other microgrid agents.
Okay. नहीं वो एक्चुअली ट्रांसलेट करेंगे सीधा हार्मोनिक पे करेंगे तो ऑसिलेशन हार्मोनिक पे होगा जो वो पर एक्टिव होगा एक्टिव पे पैसिव और हाइब्रिड किंतु एथरे एटा को ऑसिलेशन का सो ऑसिलेशन का को डिफाइन करते स्टोरेज स्मॉल सिग्नल ताकि हम कहूँ एंड कोई बात होगा डेलीकेट हाउ द
मैं बॉसी को
this is the load frequency normal load frequency control so this is the just to see here this is to break into grid dispatch break into grid controller information manage electrically charge system power grid and whatever I call communication information एक different layer है देखो माइक्रोग्रिड आइडियल स्टेट को देखो एक्सीलेटर बहुत बड़ा लिया
real time how much it is contributed to the grid performance?
right to understand the transmission level or in the medium voltage distribution it is not it's also microgrid picogrid
high level is not very possible.
तो मेरा डिफरेंस है
जो टोटल या मतलब है कि वो आइलैंड का रेंज है
सिलेक्ट आइलैंड का फ्रेंड तक हम आइलैंड में कितने सेकंड में रहता है कितने सेकंड में सेकंड दूसरा ठीक है जी तापर एसओसी बैटरी बैटरी चार्ज तो हम देखते हैं गोटे ट्रिप कला पर सेटा डिस्चार्ज हो जाଉଛି तो हम जे प्रॉपर एसओसी का एस्टिमेट न कर करेंगे गाड़ी सब आप एरिया में सीसी रिपोर्ट गाड़ी सब वर्क ऑन इलेक्ट्रिकल वर्क टेम्परेचर कंट्रोल commutation failure. So there may be some transient, some noise in the system. तो से noise का कोई भी पड़ेगा. Inherent delay, and that is a fixed delay. But again you get an other. What will happen? That is how you are taking only a transfer. It will be minus ds. Program load at fixed charge. That means within that delay, this controller will execute the satisfactory. This is more important to understand. Power interface से बटे छोटा component level है switching करेंगे तारों okay hardware is struck but when you go for a larger scale if you don't understand it is larger scale it is difficult to realize and it is important okay तापरे next बटन में करूँगी ये जो एज इंफिनिटी कंट्रोल ये जो तुम पहले इन्वर्टर करते हो एज इंफिनिटी कंट्रोल गैस ओके नॉर्मल इन्वर्टर कंट्रोल पर you are going for a current control loop and voltage control loop which loop is faster don't guess current is the current control loop faster than the voltage control so same time में what you are going for? You are going for a normal PI control design. You are going for the normal PI. So PI control design when you are doing, can you tell me is it going for the heuristic choice of API and AI? It is going for, is it going to exhibit a satisfactory response? Certainly not. Okay, industry also use the paper. You can argue in that sense. As of now, industry use PI control, simple PI control. We don't need any robots. They are right. But in a practical sense, it is a strong candidate and it has to be run. Inverter control you see lot of papers. The practical, the secret. The technical is okay. After that, when you go for a secret, there the industry people used to publish and do the patents also. Okay, so are you member of CPM? So these are all. So this is the augmented plant and correspondingly the controller design has to be done. Okay. Okay, these are I have already discussed. So I am just going last. Just you see here, this we are going for the state estimations. Algorithm of the EV charging. So there we are going for the event-based detections, right? Here the EV loads, data pre-processing, event detection, and the charging event activities. How to go for the data processing? You have to go for the adequate data infrastructures. Okay? You have to go through the higher signal processing in order to get the same analysis. Right? And how you have to go for the charging event activities. So for this raw data processing, what procedure you are supposed to adopt? signal processing, what procedure you are supposed to adopt? You have to go for the statistical signal processing. Statistical signal processing, where the features you have to extract in a statistical sense. That is, the ketosis, standard deviations, and all your mean and variance, right? So correspondingly, your data processing and the event detection of the charging event. This is for the generally greater than 3 kW is not mandatory. So this is with respect to the charging load identification by deep learning. Deep learning is your LSTM, your deep neural network. These are the charging load identifications by the different load, different deep learning techniques. How you extract the features and you realize the same by the EV charging load identifications by virtue of the deep learning techniques. Okay. So correspondingly, so there are a lot of things. So I don't want to discuss over the. So these some technical challenges you are noting down. These are the technical challenges. So here, as you told, the cyber security one aspect that I did not discuss till now. So what will be the impact of the cyber security? Any one of you, can you tell me how the cyber security will come in these charging structure loads? Can you tell? Yes. Tell me. For this EV charging stations, how the cyber security will come into the picture and what you are supposed to maintain? So the constant current and constant voltage control you are going to need. How the cyber security will come? Just you have a thought process. Can you tell me? Just you think about this. Attack, so cyber attack, it is only in the theoretical sense or it is practically possible? Cyber attack का क्या मतलब? This is the classifications. I am not talking about the classifications. Try to understand. You have a partial knowledge or a full knowledge about it. The topology when you are, that is called the system identifications. That means you have a partial knowledge and a full knowledge about the network. So within the partial knowledge of the network, it will extract what are the expected trajectory for it in the future. So again it will inject false data deliberately. So the inverter control reference signal तो हमारा जो जा रहा है, अगर it is not coming, it is going to track it and your error has to be minimum, but it will tamper that data. So you have to go for a resilient controller design. You can see lot of papers, resilient inverter, right? Subjected to the occurrence of any type of cyber attack. You are targeted to planning the meeting, your denial of service, false data injection, and the coordinated attacks also. Coordinated attacks means attack on cyber attacks at the different nodes at this time. Right? So, this is correspondingly now the EV charging station, if it is, so suppose you are charging, you are modeling it as a current source, because the inverter has the your current carrying capacity 1.1 to 1.2 and correspondingly you are, when you are modeling it, you are modeling as a control current source. With the 1.1 to 1.2 per unit maximum capability and probably LPNT compliance, it is there. So you tell me now, so corresponding to overcurrent relay coordination will be there. CTI, overcurrent relay coordinations. Any one of you of the relay coordination, what you are supposed to do? Power system. Relay coordination, now you proceed for this. Go, you are, how you go for the relay coordination. That is important, even if the EV charging code is there also, relay coordination will be there. interval and the backup breath selection of the primary and backup breaths. Right? So correspondingly, if my EV charging load, so यहाँ पे अगर bidirectional मेरा charging और discharging load there, with respect to the bidirectional power flow, your setting, whatever it is set for the unidirectional resources, it will your setting will get changed. You have to go for another setting. Right? So whatever with respect to the unidirectional power flow, what you are supposed to design, that will not act for this bidirectional power flow. No. But then maybe we don't know what we will discuss now. There are a lot of things. It is only a temporary. It is only a temporary. It is not possible. Okay, thank you. For the protection system, you have to go for a rigorous analysis about the problems. With the local based making only a one decision support, it will not be consistent. It may work for a certain operating point and perspective design and cost. It will not always work. Right? To go through the papers. Because with respect to the power electronics based converters, the protection plays an important role. IBR based protections. Have you gone through all these things? Sympathetic liquid, lining of protections. We go through that 10 months. Okay? So thank you. So I think I should find out what of things are there. Okay, so anything more we can interact. So these are all things based on this. There are a lot of things, but trainings are also there. This is the peer-to-peer energy market. Energy market where you are very good. Setting high frequency operate protection aspect में वो technique use करो दी high frequency component that is called grappling request. Right? To go through the grappling request where the optical CD and PD with that bandwidth will be there. Where the discussion and attenuation will not be there. That means when the attenuation and discussion of the signal is there with the normal sensor, so you will your total protection velocity will fail. So there you have to nullify this attenuation. Dynamic wireless charging impact is there. I have not gone through that. Dynamic induced. That is different. New Zealand